Hello everyone, welcome to the lecture number 5 of Engineering Mechanics. In today's lecture, we are going to learn about resolving a force in two components and resultant of a force system. Resolving a force in two components, or we can say that resolution of a force. The process of substituting a force by its components so that the net effect on the body remains the same is known as the resolution of a force. So, in this method, when we are resolving a force into two components, let us assume there is a force F acting in this direction, making an angle theta with the horizontal axis. Now this force can be resolved into two components, that is Fx in the horizontal direction and Fy in the vertical direction. Now one point to be noted here, that the force F is resolved into two components. The first is horizontal component and the second one is vertical component. Let us understand this. Let us say this is x-axis and this is y-axis. There is a force F making an angle theta with the x-axis. So this force can be resolved into two components, that is F cos theta and F sin theta. Now the question is that which component will be F cos theta and which component will be F sin theta. So always remember that the axis by which the force is making an angle, or the angle we are taking into account, this axis always contains the cos component. The axis which is making an angle with the force is always contain the cos component, and the other axis contain sine component. If instead of choosing this angle, if let us suppose this is the force F and let us say this is the angle theta, and now we have to resolve this force into two components, then this component will be F cos theta and this component will be F sin theta. So the cos component and the sine component of the force will depend upon the angle which we are taking into account. Now resolution of a force in different quadrants. Namely, this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is fourth quadrant. Let us say the force is acting in first quadrant F, making an angle theta with the horizontal, then this will be the F cos theta and this will be the F sin theta. If the force is acting in the second quadrant, let us say this one, making an angle theta with the horizontal axis, now this will be F cos theta and this will be F sin theta. Similarly, if the force is acting in the third quadrant like this, again making an angle theta with the horizontal, then this will be again F cos theta and this component will be F sine theta. Now the same force is acting in the fourth quadrant, making angle theta. Then this will be F cos theta and this will be F sin theta. So you can see that when a force is acting in different quadrants, then the components of the forces are acting according to the quadrant. In the first quadrant, if this is the theta, F cos theta is in the positive x direction and F y sin theta is in positive y direction. In second quadrant, if this is the angle theta, then the component F sin theta is acting in y positive direction, whereas F cos theta acting in the negative x direction. In the third quadrant, if this is the angle theta, then F cos theta acting in the negative direction and F sin theta acting in negative y direction. Similarly, for the fourth quadrant, if this is the force and this is the angle theta, F cos theta acting in the positive x direction and F sin theta acting in the negative y direction. Now, resultant of a force system. As we see in previous slides, the force is resolved into two components, and in this one we see that a force system containing a number of forces acting in different direction can be converted into a single force, or we can say a single resultant force having the same effect on the body. So a resultant of a force system is the single force and associated torque obtained by combining a system of forces and torques acting on a rigid body. So this is a system of force. A force F1 is acting in this direction, making an angle theta 1 with the horizontal. Force F2 making an angle theta 2 with the horizontal. Force F3 making an angle theta 3 with the horizontal, and force F4 making an angle theta 4 with the horizontal. Now this whole system of force is converted into a single force, that is R, resultant of the force, which acts in this direction making an angle theta x with the horizontal. Now there is a method to find out the resultant of a force system. Basically, this method to find the resultant is broadly categorized into two parts: graphical method and analytical method. Graphical method means that it contains only the measurements. Measurements in terms of angle and length. By using angle and length, we can calculate the resultant of forces. Whereas in analytical method, we will use the formula to calculate the resultant of a force system. Again, the graphical method is broadly classified into two parts, that is triangle law of forces and polygon law of forces. Similarly, in analytical method, it is classified into parallelogram law of forces and resolution method. So this is all for the today's lecture. In next lecture, we will see that how we can calculate or how can we use the graphical method or analytical method to find out the resultant of a force system. Happy learning.